Hello class, this is Ms. Jacoy. So the stuff we talked about in class today, I really want to try to have it down in your guys' notebook. So remember Cornell notes, because it's been a little while since we took notes. And you're going to have your paper. You're going to leave the top part for, like a title. And then you're going to fold it, so you have lots of space over here. Write your notes over here. Then you want to go back and pull out important information like, okay, this is the formula we use, right? And say what each part is doing. Oh, this part defines force. Okay, this is the part on friction, like what is friction. So that's what the left side is for, is to give yourself more information that you pulled out. So what does the stuff, the notes you took, tell you? Alright, so moving on, I really want to talk about, force and some misconceptions about force. So we do know that force equals ma. We've gotten really good at this. But a way to think about this is that force cannot exist with either a mass or acceleration. So force must have a mass and acceleration. So on Earth, this means if there is an acceleration, I'm just going to abbreviate that as if there is an acceleration, then there must be a force. So for every acceleration, there has to be a force opposite of it. So if there's no acceleration, there is no force. If there is acceleration, there is a force. I'm going to clear this, so pause it if you're not ready. So, for example, if we have, this one I like to talk about, it's kind of easy to think about, if we have an asteroid moving through space at some constant velocity, right, so if we have some constant velocity, final velocity is equal to initial, our velocity is not changing, is there a force? So anytime it asks, is there a force, ask, well, is there an acceleration? If your answer is, hey, look, it's not accelerating, it's not deaccelerating, it's constant, therefore we have no acceleration, this means that there is no force. So you always know if an object is experiencing a force, because if there is some acceleration, numbers, then therefore there must be some force that is then equal to that, but times the mass. So write down that, so really this is in your example, so restate this in your own words so that makes sense to you, the idea that, hey, it doesn't matter if it's moving or not moving. So a box on a table, same idea, there's no acceleration here, therefore there is no force here. Or no net force would be more correct. There's no net force. Another point is, alright, so we have two objects. Here's a box. Here's a slightly smaller box. They hit each other. They hit each other right here in the middle. Who experiences the bigger force? So think about that Newton's third law. So there's always an equal and opposite force, or reaction. So which box feels more force? Let's call this box A and box B. So box A's force and box B's force. So notice according to Newton's third law, they have to be equal, which is true. It doesn't matter how big they are, your mass doesn't matter, your velocity doesn't matter, how fast it's going, all that matters is that they do hit each other. So the force of A is equal and opposite, so negative. They feel a different direction of your force, right? They're going in different directions, they will feel a different direction. But they are still an equivalent amount of force, just in opposite directions. What would change, however, is your acceleration. So if your acceleration, right, if your mass is low but it feels a small force, that means your acceleration would be higher. This has a larger mass, so therefore your acceleration would be lower. Again, restate this in your notebooks, the idea that no matter what hits each other, that the forces are equal. Your accelerations will be different based on size. Moving on to talking about friction. So, friction. So, the definition technically of friction is the force resisting, right? It's against motion of, excuse that bad handwriting, motion of sliding objects against each other. So friction only exists if there is both movement, the sliding, and against. So they have to be next to each other. So friction, and it is the resist. So say we have a box, it is going to move this way. In the opposite direction, there is some friction going the opposite way of its motion, but not so much that we stop its motion in this direction. So why do we need friction? So what's happening at the molecular level is you're going to have lots of, okay, so here are your little molecules of one thing, your molecules of another. Friction is they're hitting each other and they're scraping against each other as it moves. So as this goes this way, these are going to hit and kind of push it back a little. That's what's happening at the molecular level. Why do you need friction? Well, you couldn't walk without friction. If you have no friction under your feet are going to slip. So you would never grip anything. So without friction, right, you'd never ever get a grip. Your life would be a sliding event. Life would just slide. And you wouldn't get to control where it went. So you absolutely need friction to walk, to move, to do all of those important things for life. Next up, I want to talk about what is the normal force. Alright. Normal, in math terms, normal means perpendicular to a surface. So it's perpendicular. What I mean by perpendicular is that it's at a right or 90-degree angle. So the normal force is a force that is always perpendicular to a surface. Force that is perpendicular to a surface. Alright, and when we talk about normal force, erasing this, so pause it if you need to. So force is perpendicular to a surface, but say we have a wall and you are pushing your hand against this wall. Cool guy. Pushing against this wall. Normal force is the force that it pretty much goes opposite of whatever force. So as long as you're not breaking the wall, the normal force is essentially negating any force towards it. For example, and maybe an easier example is you got a book on the table, or you got something on your table, right? Gravity is pushing this ball down. The table is pushing the ball up. However, the ball is never going to spontaneously jump away from this table. The normal force is only opposite of the gravity. It's not going to cause it to just jump up into the air. So normal force is only negating any force that's pushed against it. So write down one of these examples or both for yourself in your notebook. And then talking about, what is gravity? We already know the acceleration from gravity is at 9.8 meters per second squared. So essentially the force of gravity, written like this, on Earth, specifically, this is only on Earth, is essentially the mass times your gravitational acceleration. So this is your gravitational acceleration. So sometimes I might just write mg. This is what mg means. But your mass times the gravity is also just your weight. So weight is a force, and what it is, it's the force of gravity. Alright, hopefully this video provided you with some insight with what we are doing with forces in class. We will continue covering them, and we are going to start free body diagrams tomorrow.